Hi, this is Presh Talwalkar. Today's puzzle is something you might see on a technical interview question. Imagine you have 3 people and 11 identical coins. How many ways are there to split 11 coins to 3 people? Only the total number of coins to each person matters. So you might give 5 coins to blue, 6 coins to red, and no coins to green. Part 2 of the question. How many ways are there if each person has to get at least 1 coin? Now 5, 6, 0 would not be a solution because we have to give green at least 1 coin. So we might give green 1, red 5, and blue 5. Give these problems a try, and when you're ready, keep watching the video for the solutions. We'll start out by solving the number of ways you can split 11 coins to 3 people. We'll use a trick, which is to place 2 dividers between the coins. We'll color one divider blue and another divider red. The number of coins to the left of the blue divider will be the number of coins that blue gets. The number of coins between the dividers will be the number of coins that red gets. And the number of coins to the right of the red divider will be the number of coin that green gets. So if I place the dividers in the following positions, there are 3 coins to the left of the blue divider that go to blue. There are 6 coins in between the divider, that's how many red gets. And there are 2 coins to the right of the red divider which go to green. We can change the positions of these dividers. If I move the blue divider over, now blue is getting 5 coins, red is getting 4 coins, and green is getting 2 coins. I can change the positions again. If I move the blue divider all the way over to the left, now there are no coins to the left of the blue divider. So blue is getting 0 coins. In between the dividers is 7 coins that go to red, and to the right of the red divider is 4 coins that go to green. Imagine I shift the dividers over like this. Now blue is getting 6 coins. The 2 dividers are next to each other. There are no coins, so that means red gets no coins, and green gets the remaining 5 coins. I'll let you figure out how to have a division where green gets 0 coins. But basically, we can count the number of ways to split 11 coins to 3 identical people by figuring out the number of ways we can place these 2 dividers. So imagine we have 11 plus 2, which is 13 total slots. We're going to place the dividers in 2 of these slots and the coins in the remaining slots. So we want to pick 2 of the spots for the dividers, and then we place the remaining slots, we fill them with the coins. So we can count the number of ways to split 11 coins to 3 people by counting the number of ways that we can pick the 2 dividers in 13 slots. That's the number of ways you can choose 2 elements from 13, which is a binomial coefficient 13 choose 2, which ends up being 78. So that's part 1 answer, is that you can have 78 ways to split 11 coins to 3 people. Let's generalize this. Let's assume we have n identical items that we want to divide to r people. As we did before, we basically want to use r-1 dividers. We're going to need to draw out n plus r-1 slots, of which we're going to pick r-1 dividers. So it's the number of ways that we can choose r-1 elements from n plus r-1, which will be n plus r-1 choose r-1, which is equivalently n plus r-1 choose n. There's another way you can think about this solution. Imagine the algebraic equation x1 plus x2 all the way up to xr, r variables, being equal to n, and we want to find the number of non-negative integer solutions. This is exactly partitioning n into r different spaces. So this also gives you the amount of distinct non-negative integer solutions to this equation. You can interpret each term xi as the amount that person I gets. So now let's proceed to the next question, which is to do the same split except each person has to get at least 1 coin. Now we don't actually have to start over. What we're going to do is a trick where we start out by giving 1 coin to each person. So now we know each person has at least 1 coins. Now we want to divide up the remaining 8 coins to the 3 people. And we can do that by dividing the 8 coins using our 2 divider method. So we want to divide in the same exact way, but we're just going to add, I'll just do one example to show you how this works. Imagine I put the dividers here, There's one coin to the left of the blue divider, but blue already has one coin, so blue ends up with 2 coins. Now in between the divider, there are 6 coins, but then we're going to add the one that red already has. To the right of the red divider is 1 coin. We add on the one that green already has to get 2. So we can find all ways to split 11 coins to 3 people where each person gets at least 1 by giving each person 1 coin and then using our 2 divider method on the 8 coins remaining. So let's go through this solution. We start out by giving 1 coin to each, so that means there are 11 minus 3, which is 8 coins. We then have to solve the problem of dividing those 8 coins into 3 people. So we're going to have 8 plus 2, which is 10 slots, of which we're going to pick the 2 spots for the dividers. As we just solved, this will be the number of ways to choose 2 elements from 10, which is 10 choose 2, which becomes 45. We can generalize this. Let's imagine we want to split n identical coins to r people so that each person gets at least 1 coin. We start out by giving 1 coin to each of the r people, so there are n minus r coins remaining. Then we want to divide the n minus r coins to r people. We've already solved this before. You use r minus 1 divisors for a total of n minus 1 spots. So this becomes the number of ways to choose r minus 1 elements from n minus 1, which is n minus 1 choose r minus 1. Algebraically, if you have the solution x1 plus x2 all the way up to xr equaling n, we now can solve for the number of positive integer solutions using n minus 1 choose r minus 1. And in this case, we again interpret xi as the amount that person I gets. Thanks for watching this video. Please subscribe to my channel. I make videos on math and game theory. You can catch me on my blog, Mind Your Decisions, which you can follow on Facebook, Google+, and Patreon. You can catch me on social media at Presh Talwalkar. And if you like this video, please check out my books. There are links in the video description.